Hey people, Pranks the Man here. This is part 2 of doing the exhaust on a mini bike. There's a couple things I didn't mention before we start out working. I mentioned the performance aspect of doing this. There's a few do's and don'ts that hurt and help the performance of the engine. I'll be covering that right now, and then we'll get back to work to building the exhaust. First, let's start with the motor. What I did to the motor to make it work better, it was actually planned. So, I'll show you what I mean. Turn the light on. See? Okay, when I did the port job, this motor can accept a screw-in muffler or a flange type. The flange type came with the motor, and it was planned on reusing the flange to make the exhaust. I didn't want a screw-in muffler because you're actually making the hole smaller for the gases to go through, and I took advantage of the bigger hole. I ground down the threads to make the hole larger to take advantage of it, and it was planned on using the flange for the exhaust, so that gave me a 1 1/4 inch diameter exit port on the engine block. And well, that was the first part. Now when I made the flange, I made sure that it was the same size. I didn't want to choke it. What I mean by choking, it would exhaust flow would come through and hit the smaller hole, and it would slow down whenever you make the piping smaller or make a flat edge in there. It's going to hamper the flow. Basically, the exhaust, when it comes out of the motor, it wants to expand when it pushes through. So this is actually giving direction from the exhaust valve. It actually had a little exhaust valve, so when it exits the small exhaust valve and hits the bigger pathway, it's going to give the gases direction of which way to flow, since it's wanting to expand. So when it exits the engine, the exhaust that is exiting will help pull what is left in the engine block besides the piston coming up and pushing it out. It'll help suck it out also. Now this is a 1 1/4 hole, so that pretty much assigned what size piping I wanted to use to make the rest of the pipe, or I'm sorry, to make the rest of the exhaust. So my pipe selection was, I think this is 1 1/2 inch black pipe. Now 1 1/2 inch black pipe is the outside diameter. I'm really not sure, but all I cared about was when I measured the inside diameter, it was 1 1/4. So I got the black pipe. It's also a thick pipe to help hold in the heat while it goes over the gas tank. That's one of the reasons why I used the black pipe. And as for the piping conduit, it still has 1 1/4 inside diameter also, which is the same as this pipe and the same as the exit port on the engine. So it's pretty much the whole inside diameter all the way through to this point. Now inside the muffler, it's going to expand going through the baffling, and when it comes out, I like to use a next size bigger piping to help give it more direction, since it's wanting to expand coming out. It's still hot gases, so this pipe is it's actually forks off a bicycle that I cut up. This would be where the handlebars go through the frame. I chopped them off at a nice angle. I figured they'd make good tailpipes. and you notice the size of the pipe. It's one size and then it chokes at the bottom, so I'll probably cut it off where it chokes or cut it off at the bend here. This bend here helps reduce noise also. Just it's a certain bend and it helps direct the sound waves to a certain direction, so you could either point it down and the sound waves will hit the ground and you won't hear it as much, or you could point them up and the sound waves will go up and you could hear it. Aircraft use this design on their engines. It's sort of a makeshift muffler that helps with the noise. So when I come back, I'll start building the muffler and show you how to do that. Okay, I'm back. Sorry for the music. There's a party going on at the park over there. Some sort of birthday party, I guess. Try to talk over it. Okay, I got the mini bike all set up. I got the tire on there. Engine mocked up where it's going to be sitting with 2 bolts in there. And I got the suspension collapsed all the way with it all the way up. That'll tell me how much room I have. What I'm going to use for the muffler is this piece of, I don't know, it's about the size of a 2x4 square tubing, sheet metal thickness, probably about 10 gauge or smaller, maybe 15 gauge, I don't know. I don't know how that stuff works anyway. I'm going to use a section of this. It's going to come off. Inlet's probably going to be off to the side, and I'm going to angle it up. Then the tailpipe will probably follow the tire. Angle it up to the top of the tire, and then have the tailpipe come out and pointing down. That'll keep down on the noise. I don't want it too loud. Somebody riding around in the neighborhood on this, somebody will just call the cops. Oh, you're riding the bike too loud. And the cop will yell at you. So when I come back, I'll have this sized up, and I'm going to cut it in half when I size it up to be able to get the baffling on the inside. Or maybe I'll just have it come straight out. I don't know. We'll see. Okay, I'm back. I got the box all cut up and a blueprint drawn and all the sheet metal cut, and I'll show you what I'm going to be doing. Start with the box. Okay, the box is there, more light. Cut the box in half. That way I can put the baffling in there. Show you the blueprint. I just laid a piece of paper down on the part. Okay, the single lines are minimum requirements for the pathways. The double lines would be the sheet metal parts. Set it up. Get a pointer. Okay. Explain the lines. You always want to know where the center is. The inlet, you know, the piping is 1 1/4, which is this part, and then I divided the whole box into 3 chambers. The first chamber, and then the second chamber is going to start here. Oh, wait a minute, I got it upside down. Dude. Okay, this is the inlet. From here to here is the inlet pipe, 1 1/4. I divided the box into 3 chambers, 3 sections. If you measure it, this is 1 1/2 inch, 1 1/2 inch, 2 inch, so the box is 5 inches long. First chamber, these are the sheet metal parts that'll be fitted in there. Minimum requirement for flow would be 1 1/4, since that's the size of the inlet pipe. So from your center, it's 5/8 pretty much from side to side from your center. So this is 1 1/4. This is your first chamber. I figure the flow and the noise comes in. The gas will fill this up, which will neutralize the space, but the sound frequencies come in, they bounce around in here, and they cancel out. That's the first chamber. When it comes out of the first chamber into the second chamber, it splits up. So you know, half of the piping diameter, which is 5/8, which explains 5/8 from the wall to the baffle, 5/8 from the wall to the baffle. Now, since the gas splits, it's going to come through past the baffling and hit this set of bafflings, that when it hits it, the gas will flow along with it, but the sound waves will hit this baffling here, which is solid sheet metal, and get thrown up into the backside of the center V. That'll cancel some of the noise out also, and then they both combine and come out the outlet, which has chambers behind here, which will absorb a little more of the noise. When it hits, it'll deflect and kind of bounce around in there. For the noise, it doesn't work too good. I've put these on my Jeep, and you've seen my exhaust. I got cherry bombs before it. Them help get rid of some of the noise. This muffler is good for flow. If you notice, there's 45 degrees all the way through, and then exit. There's no right angles. It doesn't come in and do a twisty thing that hampens the flow. This would be classified as a free-flowing muffler. It is directional sensitive, which means this has to be the inlet and this has to be the exit. It wouldn't work right if it comes in and starts hitting this. This will make turbulence and hampen the flow. I also cut it out little slats that'll be welded alongside of the box. This is going to help align the two halves together. They'll be welded right there. And then this is going to be the baffling. Now, to secure it in there, I'll be welding alongside of it, but I'll also be drilling holes here and here along with the top, and then putting, I guess, rosette welds is what you call it, to secure the sheet metal in place so it doesn't move around. One thing I noticed too on my mufflers, the center section creates a lot of negative pressure, and the two boxes, or the two halves of the box, the center part wants to vibrate, so I need to make sure the center of the box is secured to the center of the baffling real good. I'll probably cut a line in the boxes, place the sheet metal on there, and then weld on the line to make sure it's good and tight, that it doesn't vibrate. And then for the tailpipe, I'm going to use one of these, probably that much of it, angle it down. Okay, next part is just doing it. I'll get back to you when I get the sheet metal in place before I put the two halves together. Okay, for this part, I got the blueprint laid out on the part, and I got the sheet metal all cut out. Now, to secure the sheet metal on the top half, this is the top half, I'm going to be drilling holes. But to know where to drill a hole when you remove the blueprint, I just took a center punch with the blueprint laying on it and punched all the hole locations. and then this blueprint will be used for the bottom half to weld the sheet metal baffling in place. When you put the two halves together, I'm not going to have access to the inside to weld the baffling to the top half. That's where these holes come into play. These holes are going to be right over the sheet metal, so you just weld up the holes, and then the weld will secure the sheet metal baffling in place on the top half. Okay, I got the holes drilled out. This is the top half. You can see where the chambers will be. Okay, to figure out where to lay the baffling on the bottom end, I took the blueprint, I flipped it over. This is upside down with the holes center punched in it from the other one, so it'll give me spots on the other side to center punch. That way I know where to place the baffling at and weld it in. It'll be secure onto the bottom, but when you put the top on, the only way to secure it would be through these holes, and I'll weld up the holes, which will flow into the baffling and weld it solid. Okay, all the bafflings are welded in place. I just gotta get the top matched up at the bottom. And as you can see through the holes, you can see the baffling through the holes. That's where I'll be making what you call rosette welds, and then the baffling will be secured to the top half. And then I'll weld in the seams. And then the caps for the piping going in and out. Okay, I thought it'd be pretty cool to see the muffler in action. I got the baffles welded in, well tacked in. I might need to make adjustments to get the top part on, but check it out. That's how the gas is going to be flowing through, or the exhaust gas. That's pretty neat, huh? Okay, one more shot before I button it up. I still got the ends to do. That's the entrance for the inlet. I actually was able to get the welder in there to weld up the baffles better, other than the holes. Those are the holes that I welded up on this side. So it's pretty solid. This side and that side. I was even able to get the nozzle down in there to weld the center better. So I got the tailpipe on there. It's going to be sitting on the bike this way, angled out a little bit but facing down. Sides all ground down. Okay, I got the exhaust done. It's just hanging on there by one bolt. Heat shields on there. The bed and the muffler's done. Points down. One more thing to show you. Look familiar? I shall call it Mini-Me. Okay, I got the exhaust all done. Check it out. So can't imagine how much something like this would cost from, say, BMI. Probably like a couple $100 right here. I spent, I think, maybe no more than $20 in materials and a lot of know-how and tooling. The tooling I used was a 110 MIG hand grinder with a cutoff wheel, bun box for the blueprint. Anvil, hand tools, simple techniques. These are techniques you can use to build exhaust systems for cars, headers, piping from the motor going to the mufflers of course, and then the tailpipes. These are the techniques pros use. Those guys building those cars on those car shows, that's how they do it. I'm sure they don't use twisty ties to make the lines around the bent tubing, but the idea is there. You adapt your idea or your technique to whatever you're able to get a hold of. I had a twisty tie. I didn't have rope or a fancy machine to do it, but the theory's there. It worked out pretty good. It should perform pretty good as far as I can tell. Don't know how loud it'll be, but it'll work. This is Pranks the Man. Rate the video, comment, any questions, subscribe. Bye.